Ever wondered how Kubernetes configuration works to manage complex applications? It's a fascinating topic that's key to understanding modern software deployment. Kubernetes configuration is the backbone of the Kubernetes system, a powerful tool designed to automate, scale, and maintain containerized applications. In essence, Kubernetes configuration is all about setting up and controlling the behavior of your applications within the Kubernetes environment. It's like a conductor orchestrating a symphony, ensuring every instrument, or in this case, every application, runs in harmony. It's a crucial aspect of Kubernetes, as it allows for the efficient management of resources, ensuring applications are running smoothly and efficiently. The components involved in Kubernetes configuration include config maps, secrets, and deployment files, among others. Each plays a distinct role in defining how your applications behave and interact within the Kubernetes environment. So why should you care about Kubernetes configuration? Well, it's simple. With a good grasp of Kubernetes configuration, you can effectively manage complex applications, improve efficiency, and reduce potential errors. Stay tuned as we delve deeper into the details of Kubernetes configuration. So, what are the key components that make up Kubernetes configuration? Let's delve into the heart of Kubernetes configuration and explore its key components: config maps, secrets, and environment variables. Each of these components plays a pivotal role in managing application configurations, and it's through their interaction that Kubernetes configuration truly shines. First off, let's talk about config maps. Config maps allow you to decouple environment-specific configuration details from your application's artifacts, making your applications easier to develop, update, and transfer between environments. They store non-sensitive, plain text configuration settings, which can be consumed by pods and used to adjust the behavior of your applications. But what if you need to manage sensitive data, such as passwords or API keys? That's where secrets come in. Secrets provide a mechanism for storing confidential information. Unlike config maps, secrets are intended to store sensitive and private data. They ensure this sensitive information is used in a safe and controlled manner, keeping your applications secure. Finally, we have environment variables. These are key value pairs that can be created wherever you launch your pod or container. Environment variables are a simple way to adjust the behavior of an application without having to modify the application's code or config maps. They can be used to store non-sensitive data and are perfect for situations where you need to change the behavior of an application based on the environment in which it's running. The beauty of Kubernetes configuration lies in how these components interact with each other. Config maps, secrets, and environment variables can all be used in conjunction to create a flexible and secure configuration system. They allow you to manage your application configurations in a way that's not only efficient but also secure, ensuring your applications run smoothly and safely, no matter the environment. As we can see, each component in Kubernetes configuration plays a vital role in managing and maintaining our applications. Now that we understand the components, how does Kubernetes configuration actually function? Let's dive into the fascinating world of Kubernetes configuration. The configuration process is a well-orchestrated symphony, with each element playing its part to perfection. At the heart of this process are config maps and secrets, the storage units for configuration data. Config maps, true to their name, map configuration settings to Kubernetes applications. They allow you to decouple configuration details from pod specifications. You can think of them as a dictionary, with each key value pair storing a specific configuration detail. Whether it's a property file, a command line argument, or an environment variable, config maps can handle it all. On the other hand, secrets are the keepers of sensitive data. They store and manage sensitive information like passwords, oath tokens, and SSH keys, keeping them away from prying eyes. Secrets can be created directly via the Kubernetes API or as files and then loaded into a pod. Now, how do these config maps and secrets connect with the applications? This is where environment variables step in. They act as the link between configuration data and applications. Environment variables consume data from config maps and secrets and make them available to the applications. They essentially provide the applications with the required settings and sensitive information to function correctly. This interplay of config maps, secrets, and environment variables is what makes Kubernetes configuration so efficient. It ensures that configuration data is securely stored and readily available when needed, thereby ensuring the smooth operation of applications. Moreover, by segregating configuration data from application code, Kubernetes configuration promotes a clean separation of concerns. This means developers can focus on coding the application logic, while the configuration details are managed separately, enhancing the overall maintainability and scalability of applications. So, there you have it, a bird's-eye view of the working of Kubernetes configuration. From storing configuration data in config maps and secrets, to making it available to applications via environment variables. This process is all about efficient and secure management of configuration data. Understanding the working of Kubernetes configuration helps us appreciate its efficiency in managing complex applications. What are some of the best practices when it comes to Kubernetes configuration? Let's delve into a few key strategies to make the most out of Kubernetes configuration. Firstly, safeguarding config maps and secrets is paramount. These hold sensitive data, and a breach could compromise your entire system. Implement access controls, encrypt data at rest and in transit, and limit who can view and modify them. Secondly, make judicious use of environment variables. These can be a powerful tool, but also a double-edged sword. Over-reliance or misuse can lead to configuration sprawl and complexity. Keep it simple and well documented. Lastly, regularly audit and update configurations. This isn't a set-and-forget scenario. As your system evolves, so should your configurations. Regular audits help identify outdated or unnecessary configurations and keep your system lean and efficient. By following these best practices, we can maximize the benefits of Kubernetes configuration. So, to sum it all up, we've journeyed through the fascinating world of Kubernetes configuration, a vital cog in the machinery of managing complex applications. We've explored its various components, each playing a unique role in orchestrating the perfect symphony of operations. We delved into the inner workings of Kubernetes configuration, examining how it streamlines processes and enhances efficiency. By automating deployment, scaling, and management, it transforms the way we handle applications. Our journey also took us through the best practices for Kubernetes configuration. Implementing these not only optimizes system performance but also safeguards your configuration against potential pitfalls. Prioritizing security, maintaining simplicity, and promoting transparency are just a few of these best practices that can elevate your Kubernetes experience. In essence, Kubernetes configuration is a robust toolset that, when wielded correctly, can revolutionize the management of intricate applications. Remember, Kubernetes configuration is a powerful tool for managing complex applications efficiently. So,